Lesson 13.2, we're looking at angles and radian measures. In the upper left-hand corner, I have an angle drawn on a coordinate plane. The initial side is where the angle starts, that's the first ray, and then we rotate counterclockwise, and the second ray is going to be called the terminal side. So this looks like it could be maybe 150 degrees. We could have rotated clockwise, and if we would have stopped here, then that would have been a negative 90 degrees rotation. So the first example asks us to rotate 135 degrees. It's positive, so we're going to go counterclockwise. And maybe 135 degrees might end right about there. Now we'll look at 640 degrees, which is more than a circle. We know a circle is 360 degrees. So since a circle is 360 degrees, what we could do is take the 640 degrees, subtract one full circle, 360, that leaves us at 280 degrees. So we would make one complete rotation, and then we know we're going to go around one more time and stop at 280. So 90, 180, 270, and then just a little bit more. So it would be right here. So it's a little bit tricky to look at. So we could simply just draw our 280 degrees like that. Our last one is negative 105. So we are not going counterclockwise, we're going just clockwise. So we start, we end up with 90, and then just a little bit past 90. So probably right about there. I'm just going to erase that so it looks a little bit nicer. So that might be negative 105. So in your notes, you might make sure that you know that counterclockwise would be if it's a positive, and it's going to be clockwise if it's a negative. Now we'll go to coterminal. All right, so now we have a coterminal. So coterminal means that the terminal sides are going to coincide, and that happens by adding or subtracting multiples of 360. So we could add 360, add 720, because that's a multiple of 360. We could subtract 360, and we'll get the second side of our angle, that second ray, is going to be at the same spot. So for instance, with negative 215, I can add 360 degrees. So negative 215 on this graph, this is negative 180, we'd go a little bit more, so maybe something like this would be negative 215. But when we add 360, we get a positive 145 degrees. So now, if we look at this terminal side, doesn't it look like 145 degrees? So now we have 570 degrees. So we could subtract 360 degrees and get 210 degrees. We could take the 570 and add 360 degrees and get 930 degrees. We could take that 570 and add a multiple of 360, which is 720, and get 1,290 degrees. So all of the terminal sides would be the exact same place on the graph. All right, now we're down here and we're going to take a look at radians. A radian is the measure of an angle whose terminal side intercepts an arc of length r. So if you look, arc length equals radius. So it has a radius of 1. So if that's true, and we take circumference equals 2 pi, and we know r, but here we're saying that if it has a radius of 1, c equals 2 pi times 1. And 1 times anything is just going to give us our value. So circumference equals 2 pi. Now let's look at the circle here. The red is indicated in degrees, which we're used to using, but now we're going to look at radian measures. So notice that 90 degrees is pi over 2. Make sure you know that. 180 degrees is pi. And that makes sense because the full circle is going to be 2 pi. The circumference is 2 pi. So halfway around is just 1 pi. And then we have our 270 degrees is 3 pi over 2. So the main thing here you need to know right now is that pi radian equals 180 degrees. We're going to be using that primarily today. And I should say before we click over to the next slide that you need to know this. So be sure to copy down this circle. It's very important. And for right now, we just need the values that I circled, but make sure you copy down the circle in your notes. The next thing you're going to do, you're going to add to your notes is this. To convert degrees to radians, we're going to multiply by a fraction. The numerator is pi radians over 180 degrees. And then if we want to change radians to degree, we're going to multiply by the reciprocal, which is 180 degrees over pi radians. So this is very important. You're going to put this in your notes. All right. So this one says we have 75 degrees. So we take 75 times, and we're going to multiply by pi radians over 180. We can do a little bit of cross-canceling. So if I divide by 15, I end up getting 5 pi over 12 radians. 15 goes into 75 5 times, 15 goes into 180 12 times. In this next one, we're changing radians to degree, so we're going to be using 180 degrees over pi radians. So we take our negative 5 pi over 4, multiply it by 180 degrees over pi radians, and we can see that I forgot to write my radian. Anyway, we can cancel these out because I forgot to write my radians. And then divide by 4, so that's 1. Divide 180 by 4, that's 45. So we end up getting negative 225 degrees. All right, so sorry about that. I just squished in my radian because it should have said negative 5 pi radians, and then we could cross cancel everything. All right, so now we're going to look at arc length and area. The next thing you're going to put in your notes would be our arc length equations here and area. So pause the video and put that in your notes. So we're given some values. We're given r equals 18 meters and theta here is 25 degrees. And we're asked to find the arc length and area. So we're going to start with our arc length. So we tend to want to just start subbing in values, but we can't do that quite yet. Before we can do that, we first must change theta to radians before we begin. So I'm going to pause the video and do that. All right, so here is where we converted our theta. I did some cross canceling and got this answer. So now I just had to put that into my equation. So we said that r was equal to 18, and then here I have my fraction. We can do some cross canceling. 18 goes into 18 once. 18 into 36 is 2, so it's equal to 5 pi over 2. And if you wanted to, you could put that into your calculator and get a decimal answer. Now let's look at area. So for area, we have 1/2, and we have 18 squared, and that's from over here, given. We have our 5 pi over 36. 1/2 and 18 squared is 324. And we still have our 5 pi over 36. And then when we multiply, we get 162 times 5 pi over 36. We can divide 36 by 18 and we get 2. 162 divided by 18 is going to be 9. So the 9 times the 5 pi gives me 45 pi all over 2. And if you put that into your calculator, I think it comes out to approximately equal to 70.686 meters squared. And remember, the answer is going to be squared because it's area.